So, what are RAG agents and vector databases in super simple terms? Understanding how RAG agents and vector databases work can seem complex, but we can break it down into simple concepts. This video will explain these technologies using straightforward analogies and visual examples to make these powerful AI tools accessible to everyone. You will, after this video, understand RAG agents, vector databases in the most simple ways possible. But before we do that, before we talk about RAG agents and vector databases, you need to understand embedding models and how they work. Embedding models simply turn words into coordinates. Why do they do that? To process language, computers need to understand words as numbers. An embedding model converts words, phrases, or entire sentences into a long list of numbers called a vector. Think of this vector as a unique coordinate for the text or data. Imagine Google Maps for meaning. Every piece of text, a word, a sentence, or even a paragraph gets its own unique set of coordinates. These aren't latitude or longitude, they're 1,536 numbers long vectors. This is a vector store on N8N, a vector database, and this is the embedding model, which is OpenAI. The same text will always generate the exact same coordinates. So to recap, for computers to process language, they have to read it in numbers. So the way we store data into vector databases for the AI agent or workflow to retrieve data from, we store it using an embedding model. We turn the words or the data into numbers, which are vectors, and only then can we actually retrieve data later on. That's how we store, and that's how computers read the data or process the language. Similar meanings equal close coordinates. So the way we store these data or the texts or the language, when the embedding model turns the words into vectors, and we mentioned that vectors are coordinates in the vector database, when we say coordinates, they are coordinates of meaning. The embedding model stores the data based on meaning. For example, dog and puppy have similar meanings. So once we send dog and puppy into the embedding model for it to turn them into vectors and store them in the vector database, the coordinates they get are going to be close to each other. Reason being is they have similar meanings. So the way we store data in vector databases is based on meaning. So if they have similar meaning, they get stored beside each other. If they have different meanings like volcano, they get stored in a different place or different area far from dog and puppy. So the magic happens here. Texts with similar meanings are mapped to coordinates that are close together in the space, as I just told you. Example, dog and puppy will be very close, dog and volcano will be very far apart. Simple. Vector database. For you to understand vector databases in the most simple way possible, I'm going to give you the best analogy out there. It's the big ocean analogy. Consider the vector database to be a big ocean. A vector database like Supabase with pgvector or Pinecone or whatever is a giant ocean where every fish is a vector and every fish is stored in that vector database. So if the vector database has vectors inside it, which are coordinates for data, if the vector database is the ocean, the vectors are going to be the fish inside the ocean. Very simple analogy. Each fish's position in the water is its vector coordinates. You can store extra information with the fish, metadata like title, author, link, name, email, etc. So once we store vectors or we store data in the vector database, we can add to that vector metadata like title, name, email, phone number for us to be able to like have it simple when we identify the vectors and pull them back, we can identify them easier with this metadata with them. Query or the fishing line. By the way, this might still sound complicated, but just give me 5 minutes. I'll combine all of this together and you're going to understand it guaranteed. So a query is the fishing line. Every time you ask a question to the RAG agent, the embedding process occurs once again. So the same way we embed data, we turn words into vectors through the embedding model to store data. Every time we ask a question, we must do the same thing using the same embedding model. because computers need to process language. And the same way we turn them into vectors, we turn data into vectors for computers to process data, we need to turn the questions or the queries, synonyms, we need to turn the queries into vectors for the computer to process them and find the answers. So the same embedding process occurs. Your question is embedded, turned into coordinates with the same embedding model you use to store your data. And here we have a fishing hook. So this embedding is your fishing hook. So the question is embedded, turned into vectors, and it becomes your query, your fishing hook. Only then can you search for the answers. And in vector databases, or at least the vector databases we're going to be building, they follow the nearest neighbor search. So let's go back to the basics we mentioned a few minutes ago. Vector databases store data based on meaning, and data with similar meaning are stored beside each other. So if we want to find a certain answer with a certain meaning, we need to measure the distance. Let me explain. So the vector database takes your hook, which is the question, which is the query, and measures the distance between your hook and every fish in the ocean. So this is your query, this is your question. The vector database measures the distance between this query, like these coordinates, and all the other fish in the ocean or in the vector database. And then it finds the closest fish. Why does it find the closest fish? Because the query has been embedded using the same embedding model and turned into vectors based on meaning. I'm going to give you an example to actually explain it fully. So let's say the question was, what ice cream flavors do you have? If we put this through the embedding model and it turns into coordinates, it's going to be placed over here. And we said that similar coordinates mean similar meanings. So if we have data that has been placed in the vector database a while ago, which is strawberry, vanilla, and chocolate ice cream flavors, it most probably is going to be stored near the query. Why? Because it has similar meaning. So if we have strawberry, vanilla, and chocolate ice cream flavors already stored in the vector database, and we add or we place the query, which is also talking about ice cream flavors, in the vector database, it must have the same coordinates because it has a very similar meaning. This means if we throw that hook, that question, that query into the database, the vector database, and we find the nearest neighbors beside that, around that query, and we pull them back and we retrieve that data, the nearest neighbors, this should give us relevant answers. This should give us the strawberry, vanilla, and chocolate flavors because they have similar meanings. I'm going to repeat that one final sentence. So if the query is placed here based on coordinates that is based on meaning, let's say the meaning behind the sentence is ice cream flavors. If it got placed here, the vectors the vectors that are the nearest to this query must have the answer, which is strawberry, vanilla, and chocolate flavors, because they carry the same meaning. This is why, after we throw the hook into the vector database and we find the nearest neighbors, the RAG, or the retrieval augmented generation agent, catches and feeds the LLM. What does that mean? So it catches the nearest vectors, which are going to be strawberry, vanilla, and chocolate for a fact, because they have a very similar meaning. It's going to catch those vectors and throw them back into the LLM, which is the large language model. It will also throw into the LLM the query, which is the question. This way, the LLM will have the question and the possible data that it might need to read and use to process, analyze, and answer the question and give me an answer based on the data that we have. In this case, after all of this is done, the LLM uses them as context, so it answers with real relevant information instead of guessing. After all of this is done, it can finally answer my question, which is about ice cream flavors, with the answers that it pulled out from the vector database based on the meaning, the nearest meaning, or the nearest coordinates. And the answer would be strawberry, vanilla, and chocolate flavors. This is the simplest way someone can explain RAG and vector databases to you. So I'm gonna recap it one more time for you to fully understand it. So the fishing analogy. If the ocean is the vector database, the fish are the stored vectors. The fishing hook or the net is the query embedding. Casting the net is sending the query or sending the question. Pulling back the net is retrieving the vectors that are nearest to the query. Cooking the fish is the LLM processing the answer. So the embedding model turns your data or your words into numbers, which are vectors, so that computers can process language. Those vectors have coordinates and are placed in the vector database based on meaning. They are stored based on the meaning they carry. Once you have a question, we use the same embedding model to turn that question into a vector so that we can throw that vector into the vector database, find the nearest coordinates or the nearest vectors beside that newly added query, which is the question, into the vector database. The nearest neighbors must have the answer because they should have a similar meaning because they are placed near that query or that question. And if they have very similar coordinates, this means that they have similar meanings. In the example of ice cream, if I ask about ice cream flavors and this it gets placed in this area, the vectors beside it should have the answer, which is strawberry, vanilla, and chocolate flavors. This is why the RAG pulls back the vectors that are near that query, throws all of that with the question into the LLM, and this is when the LLM can give us an answer after it processes and analyzes the inputs. It gives us back the answer based on real data from the vector database. This is simply how RAG agents, vector databases interact with each other. Key points to remember. You're not retrieving vector stores, you are retrieving vectors from a vector store, which is the database. The area you land in is determined entirely by meaning and not keywords. If your embedding model changes, your ocean changes too. Old fish won't match the new hook. I'm going to explain that in a few. Without RAG, without the retrieval augmented generation, the LLM has to guess from its training data. With RAG, it reads fresh, private, or domain specific info. I'm going to give you an example. If you have a company and you ask ChatGPT about the internal policy or sensitive secret information about that company, ChatGPT is not going to be able to answer your questions. But if you connect an LLM or something like ChatGPT to a vector database for that company, which has access, which has that sensitive information or data stored in the vector database, and then you ask ChatGPT a question, ChatGPT or an LLM or a RAG agent is going to be able to check the vector database and retrieve data from it so that it can answer a question. This is the difference between the two. The final slide, why changing embedding models breaks your vector database. Yes, you would lose search compatibility with what you already have built, and here's why. Different models means different maps. OpenAI's text embedding 3 large might output 1536 dimensions with one internal meaning space, but Cohere's embed English v3.0 outputs 1024 dimensions with a different meaning space. So coordinates from one model don't line up with coordinates from another, even if the text is identical. This means distance calculations become meaningless. Vector search works because the same embedding model is used both when you store your data and you query with a user's question. Every time you store the data, you use the same embedding model to turn it into vectors. Every time you ask a question or you have a query, you turn that question into a vector as well, using the same embedding model. And that is why it works without breaking. If you switch the model, your new fishing hook is for a different ocean map. The fish you pull up won't be relevant. This is, ladies and gentlemen, what RAG agents, vector databases are. This is how they work. I hope this video helped you understand them in simple terms. And thank you for watching. See you on the next one.